Significant figures. Now, to understand significant figures, we shall take an example. Suppose if we want to measure the length of this marker, then I can do that by using this centimeter scale, and upon measuring, I found it to be the length of this marker is around 13.1 centimeter. So the length of this marker L, this is 13.1 centimeter. Now these digits 1, 3 and this 0.1, they are known as significant figures because we can measure these digits here. Alright, so this one here, the first two, or the first two digits, these are known as the reliable digits. Reliable digits. And this last digit here is known as the first uncertain digit. First uncertain digit. Okay, so that is these are significant figures. Now some instruments, they are highly accurate. They can measure up to 4 significant figures. Some can measure up to 5 significant figures, okay, depending upon the instrument, the accuracy of the least count of the instrument. For example, the vernier caliper can measure up to around 4 significant figures. You can see here, using a scale, I can measure up to 0.1 centimeter. But if you have a vernier caliper, you can even find this. See here you have 13.1 centimeter, right? Using the regular scale. But using a vernier caliper, I can get another significant figure here. Using a screw gauge, I can get another significant or another digit here. So a vernier caliper, using a vernier caliper, I can get 4 significant figures. Okay, so I can measure the length of any object up to 4 significant figures. Now there are rules concerning these significant figures, okay, how to determine this significant figures. And these are the rules in determining the number of significant figures. So the first rule is that all the non-zero digits are significant. For example, 1, 2, 3, 4. If you have this number here, then all these are significant figures. And even this 5. Suppose you have this 56.5 centimeter. Then all these non-zero digits, they are significant figures. So here we have 4 significant figure, and here we have 3 significant figures. So that is the first rule. All non-zero digits are significant. Then the second rule is that all the zeros between 2 non-zero digits are significant, no matter where the decimal point is, if at all there is a decimal point. So for example, this number 306. Now this 0 here, which is in between the non-zero, is significant. So here we have 1, 2, 3 significant figure. So here we have 3 significant figure. Then if we have this number here, 1, say 1, 0, 0, 2.305. Now again, these 2 digits, non-zero zero digits here, they are significant because they are in between the 2 non-zero digits. So even this also is significant because it is between this non-digit number 3 and 5. So here we have 1, 2, 3, 4, 5, 6, 7 significant figures. So here we have 3. Here we have 7 significant figures. So that's the second rule. Then the third rule. Now if the number is less than 1, the 0 or zeros on the right of the decimal point but to the left of the first non-zero digit are not significant. Okay, so if it is less than 1, say number 0.002308, so this number is less than 1. So now this 0 here, these zeros, even this, they are not significant. Okay, so these zeros, they only tell the place of the decimal point. Hence, these are non-significant. But this 0 here, it is between the non-zero, so this 0 here is significant. So in this case, we have 1, 2, 3, 4, 4 significant figures. Okay, so that's the third rule. These zeros, which only indicate the decimal point, they are not significant. Then the fourth rule. Now the trailing zeros in a number without a decimal point are not significant. So if we have a number without a decimal point, for example 1, 2, 3, 0, 0 centimeter. So here we don't have any decimal point. So these zeros after this number here 3, they are not significant. So in this case we have only 1, 2 and 3 significant figures. But if there's a decimal point, then these zeros are significant. Okay, so that comes to the fifth rule. In the fifth rule, the trailing zeros in a number with a decimal point are significant. For example, you have this number here, 3.500. Then these zeros, because we have a decimal point here, so the trailing zeros, they are significant. So in this case we have 1, 2, 3, 4 significant figures. Even if we have this number also, another number 0.0690. Now these trailing zeros here, 2 trailing zeros, they are significant because they are after the decimal point. So here we have 1, 2 which are significant, then the 9 and 6, they are significant, and this 0 here, these 2 zeros, they are not significant using this third rule here. Okay, so using the third rule, these are not significant, and using the fifth rule, the 0 here, they are significant. So in this case we have 4 significant figures. Okay, so we have these 5 basic rules to determine the number of significant figures. So the first rule, here we have 1, 2, 3, 4 significant figures. Here we have 1, 2, 3 significant figures because they are non-zero. Here we have 1, 2, 3. Here we have 1, 2, 3, 4, 5, 6, 7 significant figures. Now here we have, these are not significant, so we have 1, 2, 3, 4. So here we have 4 significant figures, and here these trailing zeros, because they don't have a decimal point, unlike here. So here these are not significant. So only 1, 2, 3. So we have 3 significant figures for rule 4, and for rule number 5, here because we have a decimal point, so the trailing zeros, they are significant. So here we have 3, 5, 0, 0, 4 significant figures. Again here, because we have a decimal point here, the trailing zeros, they are significant. So we have 1, 2, 3, 4 significant figures, and these, they are not significant because using this rule 3. Okay, so this is how you will determine the number of significant figures. Now we have one point of observation here. That is, if we have say a number or a quantity whose length is measured to be 4.700 meter. Now these two zeros, they are significant because we have a decimal point here. So the trailing zero, they are significant, and these being non-zero digits, they are also significant. So here we have 1, 2, 3, 4 significant figures. Okay, so in this quantity, it has 4 significant figures. Now if I convert this one into millimeter, so to convert this into millimeter, 4.700, if I want to convert meter into millimeter, I'll have to multiply this with 1000. So this will become millimeter. Okay, so this on conversion to millimeter will be equal to 4. If you multiply this, you'll get 4700 millimeter. So this value and this value, they are same. But you can see here, the number of significant figures is different. Okay, so 4.700, these are the significant figures, which is 4 significant figures. But in this case, you can see here, we don't have a decimal point. Okay, so we have 4700 and there's no decimal point, which means that the trailing zero, because they don't have a decimal point, they are not significant. So these 0 here, they are not significant. So the significant figure here is 2. In this number, the significant figure are 2. But we have one rule, is that if we convert the unit from one system to another system, the number of significant figures should not change. Okay, so you remember that a choice of change of different units does not change the number of significant figures in the measurement. In this case, we convert from meter to millimeter. The number of significant figure here is 4, and the number of significant here also should be 4. But you can see here, but by using the ruled number 4, the significant figure here is 2. So now to avoid this error here, okay, so we are making an error here because we're having only 2. So to avoid this error, whenever we convert any system of unit from one system to another, we'll always have to convert them in the scientific notation, or we have to express the conversion in the scientific notation. So what is scientific notation? Now to convert this one into millimeter, I will not do in this way. Now this 1000 here, this is equivalent to 10 to the power 3. Okay, so if you raise this 10 to the power 3, you'll get 1000. Okay, so this expression, or if I express this 4.700 meter in this way, 4.700 into 10 to the power 3 millimeter, then this expression is known as a scientific notation. So whenever we convert one system of unit to another system, we'll have to use the scientific notation. Okay, we'll have to express them in scientific notation. So here you can see here that the number of significant figures here does not change. So here we have 1, 2, 3, 4. So we have 4 significant figures. Now this 10 to the power 3 doesn't matter. Okay, this does not give any change to the significant figures. So in this first case, we have 4.700 meter. We have 4 significant figures, and 4.700 into 10 to the power 3 millimeter. We have converted, and still the number of significant figures here is 4. So here we can see the number of significant figures does not change. Even if we change the system of unit from meter to millimeter, the number of significant figures remains the same. So whenever we have to convert one system of unit to another system, make sure we make use of the scientific notation. For example, if you want to convert this again into centimeter, then what I'll do, 4.700 meter, I want to convert this into centimeter, then I'll write as 4.700 0.00. This has four significant figures. Now I'll convert into centimeter. What I'll do is I'll multiply this with 10 to the power 2 centimeter. Okay, so here the unit is meter, here the unit is centimeter. Here the number of significant figures is 4. Here the number of significant figure is 4. Okay, so it does not change the number of significant figure. So you remember this rule very carefully. If you have to convert one system to another, you express it in scientific notation. Okay, even if you want to convert this into kilometer, for example 4.700 meter, I want to convert it into kilometer, then 4.700, I'll multiply it with 10 to the power minus 3. Once I multiply with 10 to the power minus 3, it becomes kilometer. So here the unit is meter, kilometer, number of significant figure 4, number of significant figure 4. So it does not change the number of significant figure if we express in scientific notation. But if we do not express in scientific notation, the number of significant figure may change. Okay, so remember this point clearly. Next we shall come to the rules for arithmetic operations with significant figures. Now if we are multiplying any two digits, or if we are dividing any two digits, or if we are adding or subtracting any two digits, then we'll also have to take into account the significant figures of the quantities or the numbers in which we are multiplying or dividing or adding or subtracting. Okay, so we come to the first rule first. Now in this rule 1, this is for multiplication or division. Multiplication or division. So in the multiplication or division, I'll take just the example. If we have two numbers, 4.237, okay, two quantities, say 4.237 grams. So this is the unit of mass, remember, and another quantity is 2.51 centimeter cubed. Now this is the unit of volume. So we have two quantity, mass and volume, say of an object. Now if you want to find the density, of the object, then we have to divide mass by this volume. So mass is 4.237 grams and volume is 2.51 centimeter cube. So if we divide this with this, we'll get the density, and that density, upon dividing, you will get this density to be equal to 1.69 gram per centimeter cube. Now you may get some digits here. You may get some digits after this 9. However, these digits are to be ignored, because here when dividing this quantity with this, we'll have to look at the least significant figures. Which number has the least significant figure? For example, this number here, 4.237. How many significant figures do we have in this number? 1, 2, 3, 4 significant figure. And in this number, how many significant figure do you have? 1, 2, 3. So here we have 3 significant figures. So that is the least significant figure. So here also, whenever we divide this, the results also should have the least significant figure, which is 3. So here the result, I write it down as 1.69. though you may get this some digits here, okay, we'll ignore those digits and we'll just write just the three significant figures, 1, 2 and 3, which is the least, which is of this one. Another example is, okay, so another example is this one, 5.367 into 4.21. If you multiply this, okay, you can use a calculator. What you'll get is 22.59507. Now here, among between these numbers, 5.367, 4.21, which has the least significant figure? Here it has 4 significant figure, 1, 2, 3, 4. Here we have 3 significant figure, 1, 2, 3. So the result also should have 3 significant figure, but here you can see we have 1, 2, 3, 4, 5, 6, 7. So what we'll have to do is that we'll have to round it off. We'll have to round off this one into 3 significant figure, which is the least significant figure. So here what we do is we'll round it up. So this will be 22 point. We need only one digit here, okay, and this rest we'll have to round it off. And here, since we look at this digit, so we need only this first digit here. So what we have here is 9, and 9 is greater than 5. So whenever you have a number which is greater than 5, then this number you'll have to add it by 1. Okay, so here 9, if you round it off, if you round all this off, what you'll get is 6. So here the correct way of expressing this one is 22.6. Okay, how we'll get the 6? Because this is greater than 5, you add one digit here. So 5 plus 1 will be 6. So here we have 3 significant figure, which is equal to this one, which is the least significant figure among these numbers. So that is the rule in the multiplication. Now the rule in the addition or subtraction is different. So we come to addition and subtraction. So we have addition or subtraction. Here it's different, huh? So in the addition or subtraction, we only look at the number after the decimal place. For example, we have these 3 quantities of mass, 436.32 grams. Then we have 227.2 grams, and we have 0.301 grams. So let's add these 2 or 3 quantities. So upon adding the 3 quantities, what we'll get here is 1, then we have here 2, then we have 3, 2 and 3, we have 8, then we have this to be equal to 3, then this to be equal to 6, and this to be equal to 4 plus 2 is equal to 6. So upon addition, we'll get this number here, 663.821 grams. Now the rule in the addition or subtraction, which when regard to significant figures, we'll only have to look at the digit after the decimal point. So here in this first number we have how many digits? 1, 2 after the decimal point. Here we have only 2 after the decimal point, and here we have 1, 2, 3. We have 3 digits after the decimal point. So what we'll have to do is that we'll have to take the least number or the least digit after this after the decimal point. So for example, here the least is 1 digit after the decimal point. So here also in this result, we should have only 1 digit after the decimal point. Here we're having how many? 1, 2, 3. Okay, so that is not correct. This is not the correct way of expressing this quantity. So here we should have only one digit here. So here what we do is we again round this off. So this one, upon rounding it off, 663 point, if you round this off, then again you look at this digit here. If this is greater than 5, you'll have to add 1 here. If this is less than 5, then what you do is you just leave this as it is, because this is less than 5. So this, you just leave it as it is. So here we have 660.8 grams. So here how many digits we have now after decimal point? 1, which is equal to this. Okay, so this is 1 digit after decimal point, which is the least. This is 2. I'll write here, this is 3. So this is the least digit. So here also we have only 1 digit after decimal point. So this is the correct way of expressing the sum of these quantities. Okay, so remember, even in subtraction also it is the same way of expressing. We'll have to look at the number of digits after the decimal point. Okay, so if the least number of digit after decimal point, that has to be taken as the final result. Okay, like in this case. If they are more, then you'll have to round it off. Okay, so now we come to rounding off. How do we round it off? I've told you how to round it off. Okay, in multiplication also we have to round it off, and in this addition also, see, we are rounding it off. So I'll just tell you the rules of rounding off, which I've told you just now while doing multiplication and this addition. So we come to the rule of rounding off the uncertain digits. So rounding off the uncertain digits. How do we round off some digits to some significant figures? So for example, I'll take 2.746. Now how many significant figure here is? 4. 1, 2, 3, 4. So here if a question is round this to 3 significant figures. Okay, so that's the question. We'll have to round round this digit into 3 significant figures. So here we have 4. We'll have to round it off to 3 significant figures. Okay, so if we round it off to 3 significant figures, we'll have to look at this digit here. Okay, so we have 1, 2, 3. So we look at this digit here, we'll have to round this digit off. So here, since this 6 is greater than 5, then what we have to do? We'll have to add 1 to this 4 here. So if we want to round it off to 3 significant figures, then what we have to do is add 1 here, you'll get 5. So this digit is rounded off to 3 significant figures. So from 4 significant figures, we have rounded off to 3 significant figures. So that is how you round it off. Then again, if we take another digit, say 2.743. Again, this has 4 significant figures. So if you're asked to round it off to 3 significant figures, then again we count 1, 2, 3. Then you look at this digit here. We'll have to round it off to 3 significant figures, right? So here this 3 is less than 5. So if this 3 is less than 5, then this digit, you just leave it as it is. So if you round it off to 3 significant figures, then it will be 2.74. So this has 3 significant figures. If you round it off to 3 significant figure, it will be 2.74. So you always remember to look at the digits. First you count the number of significant figures, then look at the preceding digits. If it is greater than 5, you add 1 here. If it is less than 5, then you leave it as it is. Now we come to another case. Again, I'll consider an example. Okay, so again we consider this example 2.745. So again we consider the example 2.745. So in this digit, if you are asked to round this to 3 significant figures, so this has 4 significant figures, you're asked to round it to 3 significant figure. Now in this case it's different, you see, 1, 2, 3, then after the third significant figure we have 5. Unlike in the earlier case, we have digits which is less than 5 or greater than 5. Now here we're having 5 which is equal to 5. So what do we do if we have this digit here to be equal to 5? Now if this is equal to 5, then you look at this digit here, at the preceding digit, this one. If this is even, then you just leave it as it is. If it is odd, then you have to add 1. So here, since this being 5, then you look at this digit here. Since this 4 is even, if you round it off to 3, you'll get 2.74. 3 significant figures. But if we have this number here, 2.735, then this has 4 significant figure. If you round it off to 3 significant figure, again, you count 1 to 3 significant figure. Then look at this 5, this again is equal to 5. This digit here is equal to 5. And you look at this digit here, if this is odd, then you'll have to add 1. So since this is 3, which is an odd number, you'll have to add 1 here. So if you round it off to 3, you'll get 2.74. So this has 3 significant figures. Okay, so these are the rules of rounding off. Remember, if the digits is greater than 5, you'll have to add. If the digit is less than 5, then you leave it as it is. But if the digit is equal to 5, then look at the number here. If it is even, then you just leave it. Then if it is odd, then you have to add 1 here. Okay, so that is how you round off digit to certain significant figures. Now let's take an example. Here we have each side of a cube is measured to be 7.203 meter. What are the total surface area and the volume of the cube to appropriate significant figures? So we have a cube. So this is your cube. Now all the sides of the cube, they are same. Alright. So here the side of the cube is given to be 7.203 meter. We need to find the surface, total surface area. So this is one surface area, this another, then we have one back here. So we have 1, 2, 3, 4, 5 and 6. So we have 6 surface area. So the total surface area will be 6 times the area of this surface. So this is a square. So to find the area of a square, you have to multiply this with the number itself, okay, or take the square of this one. So here the surface area of the cube will be, or the total surface area. This is equal to 6 times this surface. So 6 times 7.203 whole square. So this will be meter square. So upon multiplication, okay, upon multiplication of this one, what you'll get is, you can use a calculator. You multiply this, you'll get 311.299. Then we have 254 meter square. This is upon multiplying this. Now here again you'll have to recall this rule for multiplication with regard to significant figures. So here you can see this one here. So this has 4 significant figures. So the result also should have 4. In the result also we should have 4 significant figures. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 significant figures here. So what we have to do, we'll have to round it off to 4. So from 9 significant figures, we'll have to round it off to 4 significant figures. And how we do that, we'll have to use the rule in rounding off. So here we have 1, 2, 3, 4. So we'll have to write up to here. So we look at this digit here. If this is greater than 5, then we'll have to add. So 9 being greater than 5, then you'll have to add 1 to this 2. So upon rounding off from 9 significant figures to 4 significant figures, we'll get this one. 2 plus 1, sorry, it's 2 plus 1, we'll get 3. So this is the total surface area, 311.3 meters square. Then even the volume also. Volume, if you want to find the volume, you will have to take the cube of the site. Upon taking the cube, what you'll get here is, if you multiply this using a calculator, you'll get 373.714, then 754 meter cube. Again, here we have how many significant figure? 1, 2, 3, 4. 4 significant figure. Here we have how many significant figure? 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, here also we'll have to round this 9 significant figure into 4 significant figure. So here we have 1, 2, 3, 4. And you look at this next digit here. Since 1 is less than 5, what we have to do here? We'll have to leave this as it is. So 373.7 meter cubed. So here we have 4 significant figures. So we have rounded off from 9 to 4. So this is the correct expression for the volume of the cube.